Hey guys, and welcome to How to Graph Exponential Functions. This is going to be by hand, so we're assuming that the apocalypse has indeed started. You have no access to your graphing calculator, you have no access to your phone, as well as no access to the computer or piece of technology that you're currently watching this video on right now. So this is purely by hand. So to illustrate our process here, let's start off with which one of these is easier? If I asked you A, to just draw a tiger. Okay, so if we just asked me to draw a tiger, there's the head, there's the legs, let's give it a little tail, and it's happy to see us. So that was what I would draw if you told me to draw me a tiger. Versus situation B, where now, hey, draw a tiger, but I have all these really nice points laid out for you. So I promise you this still isn't going to look great, but here we go. I'm going to give it a shot, and here's where you guys are really going to see that my artistic talent is not as great as my math talent. Let's see, I think this is going to go down here like this, and in those I think are hopefully is two legs. Down, 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 down. I think that's another leg. Down, 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 down. And that's kind of a tiger, right? But anyway, I might have missed a couple dots, clearly. But this shape of a tiger is still probably better than this one, right? Why? Because I had an outline already drawn for me. Please don't judge me too heavily on my art there. So in the same vein here, if I ask you to just graph 3 to the x, we know the general shape of exponentials. We know that they go, this is a positive, so I know it's going to go like that, but that's it, right? Versus if I told you situation B, now graph 3 to the x, and I gave you some points to follow, oh, now we can really make this look nicer. Okay, and much more accurate, even with my terrible drawing skills, much more accurate. So the point here is that when we have plotted points already, graphing is a lot easier. So our process then to graph exponentials is exactly this. 1, make a table of values. 2, plot your points. And 3, connect your dots. If you're anything like me, step 3 is going to be the hardest step out of all of them. So let's look at some examples. Alright, if we want to graph 3 to the x, step 1, make the table. So our table will have our x values, and then what happens when we plug in x to 3 to the x. I'm going to use always the old faithful values of -2, -1, 0, 1, and 2, but you can pick anything for x. But if you're not sure what to pick, I always generally encourage these 5 points because they hit some negatives, they hit 0, and they hit some positives. It paints a good picture. So 3 to the -2, this is equal to 1 over 9, or 1 over 3 squared. That's approximately 0.111111111 repeating. -1, that's 3 to the -1 power, which is 1 over 3. That's about 0.33333 forever repeating. 0, that would be 3 to the 0. Anything to the 0th power is 1. 1, 3 to the first power, that would equal 3. 2, 3 to the second power, that equals 9. So let's plot these. Alright, so at -2, we're at 0.1111111 repeating, so we're really low here. At -1, which is right here, we're at 0.33, so this is 1, this is 0.5, so 0.3333 will be somewhere around there. At 0, we're at 1, so here's 0, here's 1 right here. At 1, we're at 3, so 1's here, 3 is here. And at 2, we're at 9. 2, 9. And now, like I said, now we're in step 3, connect the dots. For me, this is the hardest step, but let me see if I can. Oh, we're getting a little wonky. There we go. Alright, there's your sketch of the graph of 3 to the x. Let's see something else. Okay, let's see something a little more complicated. What if we have 3 times 2 to the -x? Same thing, make the table. My strategy for graphing anything, anytime, anywhere is always make a table. So we have x, we have 3 times 2 to the negative x, and again I'm going to use -2, I'm going to use -1, I'm going to use 0, I'm going to use 1, and I'm going to use 2. Don't forget your order of operations. So when we plug in -2 to this, 3 times 2 to the negative times -2, this will equal -9 times negative is positive, 2 squared is 4, 3 times 4 is 12. You could also plug this into the calculator, but again, we're assuming that for some reason all technology is now dead. Plug in -1, 3 times 2 to the negative times -1. So negative times negative, that's positive. 2 to the positive 1 is 2. 3 times 2 is 6. 0. 3 times 2 to the, we'll say -0, even though it doesn't matter. 2 to the 0 is 1. 3 times 1 is 3. Plug in 1. 3 times 2 to the -1. 2 to the -1 is 1 over 2. So this will equal 3 over 2, which is also better known as 1.5. We plug in 2. 3 times 2 to the -2. 2 to the -2 is 1/4. 3 times 1/4 is 3/4 as a decimal, 0.75. So we can see that this function is indeed a decreasing function. So at -2, 12. -2 is here, 12 is here. So this is our first point. -1, 6. Here's -1, here's 6. 0, 3. 0, 3. 1. 1.5, there's 1, so 1.5 is here. 2.75, there's 2, there's 1, there's 0.5, so 0.75 will be right in here. Okay, and now best you can, 3, connect the dots. I'm actually going to try to do this backwards because I think, oh, missed that one. And we need to take an upturn. Come on, turn up there. There we go. Here, and the trick here is if you miss a dot, just make the dot bigger. There we go. So the decaying function of 3 times 2 to the -x, again, drawn by hand. Alright, let's see one more example to really bring this point home. What does the graph of 2 to the 3x look like? Again, step 1, we have no technology, so let's make a table. X, and then 2 to the 3x. Again, I'm going to use -2, -1, 0, 1, and 2, but feel free to use whatever x values you like. These are just kind of my favorite. So plug in -2, 2 times 3 to the -2. That's 2 to the -6, so that's 1 over 2 to the 6. That's 1 over 64. As a decimal, that's 0.0156. Plug in -1, so 2 to the 3rd times -1. This is 2 to the -3 power, or 1 over 2 to the 3rd, or 1 over 8. As a decimal, this is 0.125. Plug in 0. 2 times 3 to the 0 power. 3 times 0 is 0. 2 to the 0 is 1. Plug in 1. 2 to the 3rd times 1. 2 to the 3rd is 8. And plug into 2 to the 3rd times 2. 2 times 3 is 6. 2 to the 6th is 64. You'll see this last point, we don't have room on our graph because it's huge. This is large and fast exponential growth. So at -2, we're at the point 0.0156. This is basically 0, but let's see how close I can get it to there. There we go. -1, also very, very small. At 0, we're at 1. At 1, we're at 8. Come here, 8. And then at 2, we're all the way off the graph. We're at 64, which is like off my screen, even. So let me try to draw this as best I can. Connect. Got through 3, got through 4. This is going to take a very, very steep upturn. but this is a very rough sketch of the graph 2 to the 3x. So let's review, shall we? So what are the 3 steps again? A, or 1, make a table of values. 2, then plot the points. And 3, connect the dots. And again, if you're anything like me, step 3 is going to be the hardest step of them all. So I hope that helps. As always, if you guys have any questions, please don't hesitate to ask. I'm here for you guys. Thanks, and I'll see you guys again in the next video.